So, for those been around a while, you might know this joke about little Bobby tables. And basically, you know, mom must be a SQL person or a developer, so she named him drop tables. And so, you know, he starts school on the first day, and they enter his name into their database, and it drops the student table. You know, that's SQL injection. Like, have you ever heard of SQL injection? That's SQL injection. But it's also like a great example of don't act like you know more than you know, or you get yourself into trouble. And sometimes people can make big mistakes just with SQL queries, and by not joining tables correctly, you know, you could put a lot of load on a system. But at the same time, you need to get in and do this kind of thing. And the reason I finally, after about 10 years, came around and did, and I'm doing this lunch and learn is because in nearly every review I had at the end of the year, everyone that I talked to either said that they needed some basic SQL training or they needed to improve their SQL skills. And what I have found is that the majority of the folks that don't have the fundamentals down tend to take queries from folks. A developer or somebody on the database team will hand them a query, and then they'll start a whole library of queries that they have for their project, and then they run those things. But if they had to construct their own query, they couldn't do it, you know? And nor do they really even know what some of those things mean in the queries that they have. So if they're not getting the right results, they start to struggle. And so so that's, you know, that's the plan for what we'd like to achieve today, is kind of get people to a place where they can really start exploring data more to get the answers that they need. So, you know the little Bobby's tables joke? One of my favorites. Anyway. SQL humor.
It's a little played out.
I know, it's a little played. So, SQL or SQL.
You guys have played green?
Oh yeah. Oh my god. All right, hold on. Woo-hoo. You got it? Yeah. Okay. All right. So SQL. These in this first bullet point is that there are accepted standards for SQL. And but every database does things a little bit differently. What we have today as part of this Lunch and Learn is a test database that's in MySQL. MySQL really grew out of Unix, and so there are some nice things that if you know Unix, that will play really nice with MySQL. But there are differences, shortcuts and other things in different databases, depending on whether you're in SQL Server or in Oracle. Or MySQL, but the bottom line is if you use the standardization, all of these databases support the basic standardization, and everybody kind of needs to know that. These are the standards. It's the SQL 86 and then most recently the 2011. There are two types of two major groups of query types, and they fall into data manipulation language, which is the stuff that folks use almost all the time, the select, an update, an insert, a delete. You're manipulating data. That's DML. DDL is when you're creating things like a table, altering a table, dropping a table, and that's DDL. So you're defining things. Okay? What I want to say about this Lunch and Learn is that we're going to go through some basics and try to advance through that. So bear through some of this obvious stuff. in this test database that we have, two of the main tables are office and user. There's in the email that Sally sent today, there's a go-to.
Okay.
Right? And tables are made up of columns and rows. Columns display categories or types of data. So a category is a state. Types of data, they could be numbers, it could be character. And rows are the entries in that database. And one of the things that you see here, just as an example, state is a category, a zip is a category. The row and the entries are all of these interesting people, like George Clinton, for example. And so select queries. When we're dealing with selects, this is the stuff everybody thinks they know, which is that we select from a table where, and we put columns of information of what we intend to retrieve in a select statement, right? So that's what we have here. Select ID, first name, last name from user, where the last name is Clinton. And the parts of this SQL statement, what we have in caps are referred to as reserved words. And the select will tell you which columns that you're retrieving. And if you just put a star, you will get all of the tables, all of the columns in all of the tables that have been specified. So if you have more than one table, you will get the columns from all of those tables that are listed. And the from is telling you, from where do I need to get this data? And your where constrains the results. And of course you can use and to apply multiple restrictions or constraints. Where clauses. There are lots of different operators. This is where the different databases can come into play a little bit. But what we have here is equal to, not equal to, less than, greater than or equal to, less than or equal to, and this is also not equal to. Whoops. So bang and equal, and these two at the end, less than and greater than, are both equivalent to not equal to. Zip is character data, and so we have these ticks here, but this is where we're saying that a zip is equal to this value, where birth date is less than this value. Our last name is greater than or equal to Obama. And we'll start going through some examples. You can do combinations with where clauses. Where clauses can get fairly complex. And there are logical negations, right? So we could say where this and that, or where this or not that. And in this particular example, we're looking at zip and birth date.
So we have the last name as Obama. When are things case sensitive and when are they not? Or how do you know?
What I just learned is that MySQL is case insensitive.
Okay.
By default.
By default. And in its installation, most systems are case sensitive. And you have to be careful about that.
I would like to add, there is a parameter in some databases, there is a configuration parameter. If you use case sensitivity or if you don't use case sensitivity in the queries itself. But Oracle is an exception in that Oracle database. It's always case sensitive in the queries, and there's no way to configure that on the database level unless you use the functions, special functions, to avoid case sensitivity. So the parameter, database parameter.
Thank you.
So not only can we do combinations or logical negations, we can also deal with ranges. Sometimes people like to use greater than or less than. greater than this value and less than that value. So the alternative to that is between, or not between. So I'm going to take, oops. I'm unable to select in this view.
May I add something?
Mm-hmm.
If you go back to the screen, just, you know, I would like people to have wrong impression, but the date with 0 months and 0 day is not valid date, so we're not supposed to use this in the example. Like it has 1930, 0000. This is an error, so this query is not going to
For Oracle, but this is a MySQL database. So those are part of the nuances. And in MySQL you can define what the date format is going to be for a particular. This is the default. So he put a date in and it just transposed it. John helped me build this presentation.
I'm not saying about the format. I'm saying about the values. The months with 0 with value 0. And the day with value 0, that's not valid date at all in any database. That shouldn't be valid. If this is valid, then MySQL has a bug in that case.
Let's not get into those
I'm
kinds
saying,
of details.
Right, I'm saying just, guys, pay attention, do not use this as a rule. Like, it should be the valid date, like 0101 for example, never 0000. We have some situation. Wait. We have some situation in cb.com actually, where we have a similar date, 0 day actually. We have that. So that's why I'm saying that's really important, even at this point. So do not make this mistake.
Byron, you had an example. You had a question?
Yeah, I was looking for a little bit of guidance on some of the different criteria that are out there. What is the expected sort of convention and syntax, like indenting, for the query, like back to workbench?
My preference is to line up these items. So in this case, where you can go up and down here, and this is my preference. It's a common technique where you line up your keywords, and so that's it. When you get into longer queries, maybe with some other examples, I'll continue to do that. Okay.
So it's more vertical rows than indentation. To break it down logically.
Yeah, it's really about just being able to visually separate your keywords, and from the values that you're selecting. Another thing might be another thing that I like to do. It's not just me, but lots of people, is to do this kind of thing.
Can you tab in there?
No, no tabbing. I don't tab. No tabbing. So what's nice about this kind of method, or if you were to add in another table, I'm not going to join them right now, but what's nice about this, laying your queries out this way, is that when it comes time to needing to comment something out, you don't destroy the sort of the presentation of the query.
Yeah, definitely.
And then this thing, will still run, right, without any issue. So if you carry your commas across, then you have to do it here, comment it out here, and then it starts to look really jumbled. And then when you carry things down, you keep your ands here, and again, you know, if you need to take that out, you just, wherever I am, comment that thing, and it will still run. And so my preference is to lay out all of my queries this way. And it really just comes down to the ease of being able to comment lines in and out. And visually, if everyone is writing their queries in the same format, you don't have to spend time. It takes a lot less time to digest what's actually in the query. So moving on, we have combinations, we have ranges, and we have lists. And so, for example, this is a list. Anytime we say in or not in, we have a list on our hands.
Where were?
Thank you.
Chris, I got a question.
Mhm.
So you have the strings New York and New Jersey in quotes,
Yes.
but I've also, and what is the rule in terms of when you use quotes, when you don't? I've always been told when I have written a query to always use quotes. You don't. You ask for a discrete thing as opposed to something bigger that can cause problems.
You always use these single quotes for character data and for dates. If you put ticks around numbers, some databases will be smart enough to do an implicit conversion, which can be confusing. But you just, anytime you're dealing with a character.
Ticks around numbers work.
Because it's an oracle too, I think, sometimes. So, all right. More on where clauses. So, character matches. When we do a character match, one of the things that we need to, we start doing character matches on large data sets. Sometimes things can get really slow. And if you have a query in this case where you're trying to do these vague character matches where I need something that's just partially like this thing, and it's really slow, you ought to ask somebody who's more familiar with the database, because there can be, you can be destroying indexes. So like in this case, no matter what you do here, if there was an index on first name, it'll stop working. But an index will work when you lead, when you're at least able to lead. Always try to lead and trail with your percentages. But the percentage is like anything. What this means is, give me any first name that begins with J, I don't care what the rest is. Or give me anything that ends in AN. So the percent is a little bit like a wild card. All right, so.
And you can do double wildcards, which people yell at you for because it's a very bad query. If you search that in AN, it would be everything that had AN come up anywhere in the word. So in a big database, you think very bad things happen very quickly.
This is where we're leading, and so if you notice, Joan and Herman are returning here, and in the other example we had anybody that started with J, and we get Joan and Jim.
So this
From
is,
Sesame Street, Sesame Street.
This is preferred. Just
This
start with something and then have it.
Yeah, because you probably don't care about indexes, but it's at least good to know that if you lead with a wild card, you have no chance of getting an index if one is there. Mm-hmm.
And just as a real world example, we had this issue in LibreEdit, which basically worked fine until we added more data, and then the wildcard search basically stripped us of indexes on 15 million records, and basically with the system ground to a halt. So there's a little bit of a business rule, like in the actual code, you need to sort of define that when you're doing like a search, like if you're writing it into the code, but this is really helpful.
And,
Earlier, we talked about,
sorry, what are indexes? Can you talk more about indexes?
Sure. Byron, what did you say?
Similar to what Joel just said about, what are these indexes, where are they coming from?
Okay, an index is sort of an array of sorts that will pin exactly, if you're dealing with a column like state, and an index will tell the database exactly where every single byte of that data is in a data block, and it improves the access path. Let's say, Ohio is the state, but that value is actually spread over more than one block, or you have Ohio and you have Virginia, and we're trying to, the index will actually tell the system exactly where that data is, so to minimize the scanning that's happening. And
what I use to explain it to clients, which is very helpful, if you think of the table as sort of a traditional file cabinet, and you have markers for A through Z in there, when you go to scan the file, you're going to jump right, and you're looking for the Z, you're going to jump right to Z and retrieve the data from there, as opposed to having to start looking through the whole thing. So it helps. It's a little bit more complicated than that, just as we get into the byte level, but that's kind of conceptually why an index makes things orders of magnitude faster.
it also makes your database larger. So you don't want a system, you want to have just the right number of indexes.
Can I add something, just quickly? So, in my
Speak up, because this is being
okay,
recorded.
Okay. In the theory, the index is the set of identifiers, where every row in the table has a unique ID identifier, and this identifiers, this set of identifiers has the ID grouped by similarities. So, like Kristina already said, you don't have to you don't have to look at every row in the table, and you have to just look at the similarities and find out the ID, and then after all, the database will search for the row based on that ID, not looking at the whole set of rows. So
When you have built a query and the thing is slow and you're wondering, am I using an index? There are better ways to do this, but the way that I might expect someone without a lot of experience is to simply look at the table and look at what indexes are there and available. Like, oh, do I have an index on first name? Do I have an index on my foreign key, on Office ID? And so you would want to browse your database. This is our database. These are our tables. I'm looking right now at the user table, and I see that there are indexes listed here, and so you can expand those and try to get some details.
Can I add something? Okay. Indexes basically, as you understand now, is like list of pointers into the right direction, and it's actually very often it's in memory, it's in engine, so it makes things faster, and it points to the set of records or to particular records by ID of the record. But when you use index, or when you think about creating index, you have to think how you use your database. The rule of thumb is obviously when you insert record or update record, maybe index should be changed. So if you do a lot of selects, you use maximum number of indexes. If your database does a lot of inserts, updates, deletes, it means that every time you do this, you update indexes as well. So you slow things down from one point of view and you fasten them from the other point of view. So you have to apply balance in design. Also, in where clause, any kind of conversion, explicit, implicit kills index. This is very simple rule of thumb. So you think
Right,
that
if you put a
have
tick
this
on a number, for example, and there
Yeah.
was an index on that column, the database is going to try to be smart enough for you to convert that, to convert from string to number, but then the index disappears.
So the best usage of index to join two tables with exactly the same data type and exactly probably the same data. Once you use literals, when you use constants, you have to be really careful what you use, because it will probably go through implicit conversion as in case of dates, because it always takes as a character, and then it converts to dates. And you have to really look at where you compare your index to.
So here we're talking about where clauses. Another thing that you can do is apply functions to the columns that you're trying to constrain. An example of a function here is upper and lower. And why would we do this? Well, most databases are character sensitive. Most databases should be configured as character sensitive. And so as a result, you might have a data entry system further upstream where someone put everything in caps, and then another person entered Nixon's name in sentence case. And if you were to say, please give me everything with the last name of Nixon, all in lowercase, no data may be returned to you. All right, so you're better off in many cases when you aren't intimately familiar with this data to try to normalize it on both sides. So I'm saying that the case is the same on the right as it is on the left. This database is configured with case sensitivity, so I can't show you how this would not work. But there you have it, and you see Nixon's name, is capitalized. But from this perspective, it's capitalized on both sides. And similarly, you can lower.
Keep this. You will see that it's not working. It doesn't show.
The equal operator should be case sensitive.
Another important thing here is that unknown values, we can request unknown values. And so that means that I would like to return any value from column X where it is null, where we don't know what the value is for this thing, or where it is not null. I'm not going to show you an example of this right now because I have a whole slide on nulls, because everyone gets this wrong.
I want to add something. It's very important. Null in this perspective means actually exactly no value, nothing. You don't know what it is there. It's not zero, because zero is the value. It's not list of spaces in the character field. It's null. It means it's not null, nil, nothing, like empty. It's
I have a whole
value.
slide on this, so let's try to keep going. Where clauses in depth. So character data, it's the single quotes. We've already, and that includes dates, right? So we're going to keep going with this. Here is the trouble with nulls. So when a field is empty, it is null. Just as Olga said, it's not anything. It's not zero. It's not anything. So, what is the trouble with nulls? This is a null here, and what you need to know is that that value is not really in the database. See where it says null right there, guys? That's just MySQL workbench acknowledging that that is a null and putting a little symbol there for you. This is not the database. That's the client tool that put the null there. There is literally nothing there, okay? So when a field is empty, it is null. It's not zero. it is null, or we may be looking for things where it is not null, but we never say it is equal to null, right? So if I want to sort of make my point earlier, you see this and you say, oh, well, maybe the value that's there is actually, you know, null. So that's what I'm going to do, because I don't know any better. And I don't know any better, so I think that's what it should be. And of course I get nothing, right? But if I say is null, that value will be returned to me. And if I say is not null, I will get, now I'm explicitly dealing with my nulls. The problem with nulls is that people do not explicitly deal with them, and they cause a lot of trouble.
And you
All
tell
right.
clients lots of bad information.
So imagine, so nulls are not equal to anything. Like if you walk away with nothing today, please remember that nulls are not equal to anything. So if you say that I would like to select star from user where office is not equal to 3, okay? Let's remember how many here we have, how many rows? There are nine rows of data, right? And I'm going to say, whoops, what just happened here? We have 9 rows of data, and we have, we want not equal to 3, right? So the expectation here is we'd get 1, 2, 3, 4, 5, 6, 7. And in fact, we get 6. Like, guys, nothing is ever equal to null, so you're never going to get that. And if I say where it is equal to 3, right, I will get the remainder of the data, but you will never see that record that's null when you're trying to work like this. You'll never see that record.
How would I
And
see
so-
this record and the record with null at the same time?
Let's hang on. So,
Okay.
if we wanted to do that, you know, whoops, I better not do it that way. The best thing to do is really, at the end of the day, is to know your data, to know what you're dealing with, look at the data types and understand if a null is possible, and if it is, like, does that even matter to you, and just making sure that you're thinking about them. All right, and so here we have to put in an additional condition to handle it. This gets us into trouble a lot, you know, when you're dealing with lists also, wherein not in, oftentimes people will say, I would like to count how many rows I have in this table with people from Ohio. Where they're not from Ohio. I want everything else. I want everything else except Ohio. So they think they're getting everything, but they're not, because they're not paying attention to the nulls. And so, in fact, you're returning a count that's lower than the reality. So you even had a problem like that once, Mike? You said you had a problem like that once, where like there was a reporting error?
Oh yeah, I mean, what ends up happening is clients will say, hey, I need this special report. As the project manager, you take down the notes and you say, Kristina said, like, give me all the agents that are not assigned to an office. Or how many people are assigned to, you know, office. We also see this a lot of time in loading data, where we load nightly files and there's missing data in those loads, so you try to get these counts on it. And if you don't explicitly handle your nulls, you end up getting a false positive report to say, oh, it looks good, everyone is assigned to an office. When really you said, you know, if you didn't ask the question right, you could be missing this whole set of data that is just where there's nothing set there.
I think the best trick for just remember that this can get you into trouble. Just remember that. And then work in the positive. Like, just stay positive. Instead of saying not in, I want everything not equal to X, tell us what you do want. You know, and you're much better off if you ask for what you really want rather than saying, give me everything that's not like this thing. And so just stick to that sort of basic rule. Stay in the positive as much as possible, and remember to think about your nulls.
Can I add something? There are some parsers in some databases that are smart enough, and you can feed them equal null, but it doesn't mean that it invalidates whatever was told, whatever was said before. It just the parser implicitly converts it into not null or is null. So you can write equal null in some parsers in some databases, but it still doesn't mean that it's equal null.
Are you going to get into later field types where you can have and not have nulls, or is that outside of it?
Possibly. I think so.
Okay.
Here are just some other miscellaneous items that are really useful, guys. Your order bys. Whenever you have an order by, so we've talked about select, from, and where. Order by is sort of the next most popular clause. Most people, you know, really understand what that means. All you need to know about order by is that it will always order your data in an ascending order by default, and you have to explicitly say descending. When you're commenting, if you're in the double dash will always comment out a line. But if you are in MySQL, for example, you can use the pound, because it will accept, similar to working in Unix. So you can pound away. Another important thing that folks need to understand is that most databases, if you have more than one table in a query, more often than not, it's better practice to either alias or specify the full table before that name. So here in this case, we have user has city and office has city. Now, from a naming convention standpoint, I think this is not a good option, but this happens a lot. A database with good naming standards would avoid this kind of problem. But you can either specify the full table and the field, or you can use aliases. And aliases are actually good practice, that you really ought to alias every table that you have, because when the database is parsing the SQL itself, you're helping it by giving it an alias to parse that SQL faster. So it has to parse the SQL and then request the data. And by providing aliases, you're helping it go through that process faster. And so an alias is this here, Office O, where I'm going to show you what I mean here. I'm trying to get out of this.
You gotta hit
Exit.
You don't need to use the word as. Office as O.
You can, but you don't have to.
Need to.
That, when you say as, well, I think that's just column names. I think you're thinking about column names, like when you alias a column name, but that's more about headings. So I'll show you what you're talking about. So there is no city that's like New York City here. But there is New York, so I'm going to take that away. So, office O.City, New York. But here, what you're talking about is and another nice thing about aliases, guys, is most of these client tools, if you are aliasing, will help you, they'll just return a list of like all of the columns that are there, and they'll give you a little list, drop down, name, address, city, and you can select it rather than type it. So here, we've aliased the column name. But what Maura's talking about is maybe we want to say, we want to give this a new heading, and we want that heading to have a space. So as comes into play because I've put a space here. You can say as office name like that. Actually, this may work without the as. What, Byron?
So you can use the alias before you created it in the from statement.
No. No. The alias has to be on the table for the type ahead functionality to work. And so often I'll drop down and create my from clause and maybe my joins, and then go back to dealing with what exactly I want in my select list. And just sort of lead with a star, and then come back and refine those things last. But no, you need the alias first.
Chris, what about limit?
Limit? Row limits? Okay.
Another miscellaneous thing.
It's another miscellaneous thing. Yeah, so this table only has 3 columns, 3 rows. I can't see my errors. I'll get my errors back. Well, this works in Oracle.
So in my SQL,
Limit.
limit is actually the thing.
Huh?
You could say limit 30
01.
or limit 2.
You don't need to use the where statement.
Yeah,
It's
it's
not a
actually a
where
thing,
clause.
like a capital thing.
Limit 2?
Just nowhere.
Nowhere. Yeah.
Nowhere.
Yeah.
Okay. Well, that is not ANSI SQL, but whatever.
So why I like this in MySQL is if you're not sure about a query and it may return millions of records, as you're playing around with it, you may want to just limit it to 10 or 20 or 30 just to make sure you're getting the data back correctly, especially if you're getting into where you're naming the rows and you're doing as and you're trying to get the column headers and try to sort it out. It makes it a little bit easier to muck around with it when you're only returning back a fixed number of rows.
How do you do pagination? So if I want 10, number 10 to 20.
It's 10, comma.
Yeah.
20.
Oh, okay, cool.
Did not know that.
Yeah.
Joining. Now this is where most of the databases tend to differ. So there are different kinds of joins. An inner join is a situation where only the records with matching values are returned. They need to match on both sides of the join clause. And so this is the ANSI standard, which I would assume works in Oracle. I just never do it because they've got an easier way. So here we're saying select star from user, join office on user equal to office office ID. And we're saying this is an inner join, so I only want you to return values where there's a relationship, a hard relationship on both sides. I can't run this example for you, but in Oracle, and I believe in SQL Server, you have this opportunity here where you can literally just say join these two columns and set them equal to one another.
Kristina, that should work in MySQL.
It didn't. I tried it.
Is there a performance difference, Kristina, doing one way or the other in Oracle?
I don't think so.
No.
Ah. All right. Wonderful. Is that new? MySQL being able to do that?
Not that I know of. It's been working for a while.
All right. Outer joins. This is where everyone gets into trouble. And what I think is outer joins are really important. You need to be able to know how to do them. And so the best mental approach, the best mental strategy is to say, what is the table that I want to lead with? What is the table that I want to return the maximum amount of data from? And what is the table that I don't mind having nulls returned in? You know, so if I don't have a match, when you're doing an outer join, you are saying that you are fine with one of those tables not matching on some rows. So you are okay with allowing one of those tables to have null values. And that's an outer join. Here's the example, the ANSI example. And so here we're saying, here is our user table. It goes up to birth date, right? And then, because we've said select star here, we're returning everything from the user table and the office table where there is a relationship. But it just so happens that there is no relationship on this particular record, but we don't care. We're leading with the user table, and we're saying it's okay if I don't have a match.
And so outer is the same as left?
Mm-hmm. Oh, this is the one that doesn't work in MySQL. Oracle has a nice way of handling outer joins where you can just use this plus. So I guess MySQL simplifies the join, but they don't simplify the outer join. And what I like about this is because I'm saying, you know, there could be nulls right there, wherever I put that plus. Any question about outer joins? Because this throws everybody for a loop.
And from a performance standpoint, outer joins are more costly than inner joins?
Yes.
You see here left join. What about right join? Is there such thing like right join?
There is a right join. Most people don't do it. But yeah, you can right join, left join. I don't know. I'm not sure why right joins are discouraged, but it's possible. So just to kind of give you a sneak peek into what we're going to do and some of these, some of the next items, I want to cover aggregate, some of the most common aggregate functions. I want to talk about group by and having clauses, which play nice, very nice with aggregate functions. I want to do a little bit about data modeling and then talk to you about actually creating some of your own data. So up to this point, right, we've covered the basic core of formulating a SQL statement. Select, from, where your constraints, making more complex where clauses, and we talked about joins and different ways to select data, and then some additional tricks. And now we're going to talk about aggregate functions. So aggregate functions, you know, do just that. They aggregate your data into sets, or perform some sort of function. And in this case, these are min and max functions, and that will allow us to find the minimum and maximum value, right? Very obvious.
I have a question. Oh, okay.
Okay.
Yeah.
This is the min rating, which is 33, and the max is 93. Why would you use this? Maybe you have a table with a large amount of data, and you kind of need to know what is the range of possible values on a table, and so you might request the min or the max.
Can you do min rating, comma max rating from user? Can you get both?
I don't think so. Yeah. No.
Well,
No,
they're-
you can't.
They're both max.
They're both max. Okay.
Yeah, it just returns 2 columns.
Yeah. So yes, you can. Yes, we can. Here's the most common aggregate function, which is counting. Often people will want to count some rows from a table, and if you count star from user, where blah 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 is equal to New York, this is where nulls come into play too. Not this particular example, but I'm going to show you on the next one. So often when I have a problem and I'm trying to figure out why do my numbers not match his numbers, you know, I tend to want to lead with how many possible values am I dealing with in this table, especially when I'm dealing with a join and I'm dealing with unfamiliar data. I like to take a step back and say, how many records do I have in my user table? How many records do I have in my office table? And I know in my user table I have 9, but in my office table maybe I have 10. And when I join those things, all of a sudden I only have 7, but my target number is 9. You know, you need to think about those things because, like, you need to figure out whether or not you're writing the correct code. Counts can help a lot. And where you can just apply some simple addition to figure out whether or not you've constructed a query that's returning the correct number of results. And in this case, we have 6 from New York. So the next example, so if you want to count values in a specific column, nulls will bite you, because we will only count values that are not null, because you can't count something that doesn't exist.
Select star from pizza where unused equals 1.
Speaking of null matches.
Well, that's the full return array right here.
Do you want the whole thing?
Yes.
Where flavor equals veggie.
Are you good? You want?
Was that plain?
No.
No,
It's veggie.
not good.
Bon appetit.
Yeah, I would like it on a plain slice.
The other plain box is down there.
Don't hit the microphone on the table.
So in our user table, if we go back to this example, can I have a plain one? If we go back to this example, we know that, right, the user, the office ID has this null value, but somebody's come along and they want to know how many users are there here. And we know there are 9 records in this table, but if we explicitly try to count this column, we're only going to count 8 records. The reason for that is because you can't count nothing. It will not count that null value. Right, we have 9 records in the table. So, another nice one, and I think these are all kind of useful.
Can I add something? In this case, when we have nulls, there's always a proper function in different databases to convert null into some value. Like, for example, NVL in Oracle, so you put it inside NVL field name in brackets and change it to 0 or whatever. Or is null in SQL Server. So if you convert this column, always take care of nulls when you count by column. You will get right result.
I think it's. I don't think it'll work here. I don't want to get into like, I don't know, so count distinct. You know, how many different office IDs do we have for the user table? You know, again, if you are unfamiliar with the data that you're dealing with, running lots of count distincts, counts, knowing how many records that you're dealing with, and as you start constructing your joins is key to getting the correct answer. Summing. Find the sum of all values in a column. Sum column name, sum rating from user where office ID is equal to 1. Rating is a number. So basically we're just saying, we're just adding. That's all.
Can sum be applied to a non-numeric column?
Yes, but it is doing an implicit conversion here, right, which I think is actually happening. Because I think he did everything. Yeah, see that? This is interesting, guys. So John created this database, and he created everything as a varchar. And the rating here is not a number, you know, but MySQL is figuring that out.
No, I don't mean the type. What the data can be converted or coerced into, but say you were to apply sum to the state column.
No.
Would it produce an error, or would it produce interesting results?
Wrong results.
Oh, it didn't throw an error.
It did not throw an error. Another common one is our averages, right? Again, these are all just functions. You can make this nice. Nicify that one there, round it.
And then can you do round up to round down?
I believe so.
Kindergarten.
I think you can also specify decimals.
Can you do specific stuff like mean or median?
Yes.
You can.
Yeah, most databases have an endless set
Something
of...
to know.
What?
Something to know for average is that when it counts the number, anything that is null does not get counted.
Anything that's null is not part of the average.
Right.
Guys, nulls are like around to ruin you on everything. So what I have seen over the years is that most people will dive in and not look at their data, not scan their results, create some kind of query, not know what their target number is. You know, you need to know what you need to scan the data that you're dealing with visually with your eyes. You know, scan it, count it, know what you have, know what you're going to expect, construct a query, make sure your results match that.
How much work is done then to, for lack of better words, nullify your nulls? You know, to actually put that
To prevent
in
it?
there. No, if you have nulls, fix the data.
When you define fields, sometimes you can actually say if the field can accept a null or not.
Mm-hmm.
But to Kristina's point is you need to know if they're possibly going to be there or not.
In a transactional database, it's often unavoidable when it comes to character data. And so you have to be conscious of that all the time. In a data warehouse, nulls are just, you just cannot have a null anywhere. Because the whole point of a data warehouse is to aggregate, to group data into sets, and to perform calculations. And so if you have a null on anything, anywhere, you will get the wrong results. And so you have to null proof a data warehouse. And often they will do that like with foreign keys, where you'll have a foreign key that's equal to 99, which is sort of the universal not available kind of situation. And so some databases will null proof without applying null constraints, or they may do both. But you know, it depends. Average grouping. So you know, anytime you're using an aggregate function and you want to do a little bit more than just return a single value, you have to use group by. And group by, a group by is after the where clause and before the order by. Interestingly enough, well, they're intimately connected to aggregate functions, and they're really used to expand the usefulness of an aggregate function. So you can only get so far, you know, with an aggregate function before you are required to use a group by. So here's an example where maybe you want to count for each particular value, right? So your table names, your constraints, and then the column name. And typically, whatever is in your group by is anything that you don't have an aggregate function applied to. Okay? But what do group bys actually do? Well, this is set algebra, you know? So we are dividing a table into sets and into groups of rows. And so here's an example. I also like to do this, Byron. All right, so, oh, space is. Okay, so these are sets, you know. Alabama California, New Jersey, these are sets with sums and ratings. And so maybe we want to say, as the state rating, and improve the way that that looks. State? Count what? Count
Just
rating?
start.
Just start. So, this is telling us how many rows comprise the rating. See? So we have 3 rows of data for New York and 2 for New Jersey that comprise the sum of this rating.
Can you order the groups? I know you said you can order, so the group goes after where, before order, but then can you order?
Oh, you want to order by one of these by the state rating?
No, by the actual state. So you're grouping by state, but can you order those groups as well?
Yes, you can.
By default, it's giving it to you
Alphabetically, right, exactly.
But you could do it descending and
You can also do this. Whoops. Oops.
So Chris, in that case, since you're doing an as, you would then order by the as, not by the column name in the table?
That didn't work, did it? Pardon me?
So you're, well, I mean, that's a bad question, but, so you're using the column heading, the as, to
Yeah.
do order by, is that right?
That is, you can do both.
Either way.
You cannot do that in the group by. It has to be, but the other one didn't work in this database, so maybe not. Because I noticed when I put in state rating and it wasn't ordered correctly. I don't know if you noticed that.
So when you do group by, does it automatically do distincts?
Yeah. Yeah, because you're trying to find unique sets. So when we group, we are finding unique combinations of whatever columns we have included. So let's go back to this user table. I'll add another column.
But could you also, I mean, because I feel like we've done queries, and Dave, maybe you can help out, we get a whole list, we get a list return, and then I want to, group by distinct record.
You want to summarize only distinct?
Yeah, that's what I mean.
No, it's not.
It's not that.
No, you have to do it explicitly. What Kristina means, it's just it shows the results already distinct.
Right.
So it doesn't show the same row twice. But inside of the sum, it's not distinct. It counts every row, and summarizes every row. So you have to do some sub-query for this reason, something more explicit.
That helps.
Okay.
Can you see how this kind of formatting your queries makes it a little easier to read?
Mm-hmm.
And sometimes they get bigger and bigger, right? So it's better than one big blob, in my opinion. So I don't think we ended up with any new values there. Everybody's in a different state, but I thought maybe it would further divide the rating. But had there been more than one city for a state, it would have broken the rating out for each city-state combination.
How New Jersey's split?
Oh, it did?
Plainfield and Hoboken.
Okay. Okay.
May I add something? I would like Kristina to illustrate another way to use ordered by when we use just the column order in ordered by.
Oh yeah, all right, okay.
It's very
So we're gonna
convenient
do,
feature, but
so
good.
convenient, but
Right.
guys, don't put this in any of your code.
Right. Just for
Order by
efficiency,
one
if
and
you need to-
two.
If you need to run it really fast, quickly, you don't have to type it. So,
This is, when you're doing throwaway queries, these order bys are awesome because you don't have to type more. And all I'm saying is order by column 1 and 2. But then I could say order by column 2 and then 1. All right, and it will change, it will order by state first. So this is so handy, like Oleg said. But the problem is, and I've seen this time again, especially in Secure, where they use a lot of order bys with column numbers, and so if somebody comes along and they've got a query that runs off the page, you don't see the order by because it's the very last, one of the very last things. Somebody will change the columns that are in the select list, change the order, add an additional column, and then all of a sudden, what was in position 1 is no longer in position 1. So that's why you wouldn't put this
right.
into anything permanent.
Especially if it's useful for the column number 3, state rating. So you don't have to type this long name. But again, like Kristina said, we have to be very careful when we're using that, and like we have to check twice. So
But it seems like in a troubleshooting situation where you're building this query out and multiple people are looking at it, you say, hey, what if you sort it by this column, then that column, just to do the shorthand makes a lot of sense.
right. I would say we should never use this in the code, like in the source code. You know, we can use it just only for monitoring or for troubleshooting something, just running hands-on. Yes, ad hoc select queries. Yeah, so only for these cases. Right.
I'm glad you showed that. I should have had that on the miss page. All right. Let's see another one here. I think we went through all of these kind of where we added an additional column. You know, I think we really kind of went through this. Do you feel like you need to see more on group by?
I have a question.
Yes, Martin. Go ahead.
Can you group by using a wildcard? For example, let's say that you have a few from Sesame Street. Can you group them by?
In the group by, no.
No?
No, not in the group by, and the reason for that is because you have to be explicit about what you're grouping, because group bys can be used without aggregate functions. I don't, you know, do you have a better answer for that? You just can't put a star there.
I didn't get the
She said, can you use like a wild card or a star? Is there any shortcut? Like we have a shortcut for order by, but we don't have a shortcut for group by. No. There's no shortcut.
No.
And I think it's, you know, it's because we need to be clear about what sets we're trying to build.
I mean, how could you have a group by everything? Like, what would you return?
Well, some people will use it as an alternative to distinct. Having. Most people I talk to who have a basic handle on SQL have no idea how to use having. And I have some page numbers in here. I don't know if you've noticed, but I had passed around, I had bought a couple of this book here. And I sent a couple to Manila too, the Practical SQL Handbook. I made sure Smidar has one, and there's a couple in the office. It's an old book, but in my view, it's one of the better books with examples. And so, as I was kind of going through this, I grabbed some page numbers. So, if where puts constraints on the from clause, then having puts constraints on the group by. It is your where clause for groups. Because we're not dealing with rows anymore, we're dealing with groups of rows. So here in this basic syntax that we have here, we're counting a column and then we're saying, but only return the rows in this set with a count greater than something. And this can be a pretty powerful thing. And maybe I'll just expand on this one. I'll run this query here, and then we'll expand on the one we did earlier. So the Sesame office has an average rating, an average birth date of 1931, and the musician's office has an average birth date of 1927. But we're only averaging where those birth dates are greater than this thing. Here in this prior example, our group are having, first of all, always happens here. And here maybe we want to say, let's look at our user table first. I'll go back and look at our user table. And we know that we have a sum on rating, right? And we have a count star. But maybe we want to only do ratings where we have more than one state, because there's no point in summing a rating if we only have one of them. So, maybe we'll just put a having on that, where the count star is greater than 1. And now we're only going to average this example. There are 3 of them. But maybe we want to do it's less than 3 because that's an outlier. So we're excluding things or including, constraining the data that we want to analyze in our sets.
Can we do the same with the where?
You can have, no, you can't use an aggregate function in the where clause.
Okay.
You have to have mental distinction between where and having. Basically think about having, like you apply where to the result set after you calculated all totals and average. So after you calculated everything, you have sort of result set with particular data. Then you apply where, which is called having in this case, to this result.
So from an execution standpoint, the where constraints are applied first, and then having.
What's an
Right, and
aggregate?
really it's basically, what you're saying is it's like another where, it's like you get your results and then it's like the verb we would say normally is where there's only one
Yes,
record.
yes.
But if
So-
we use having as the command
Yes.
to do it.
What's an aggregate function again?
Counting, summing, averaging, min, max.
So even though we've used it in the select, you said you can't use an aggregate function with group by?
You can't use an aggregate function in the where clause.
Oh, okay. Just in the select.
Mm-hmm.
Okay.
Now here's something else, guys. You don't have to have an aggregate function in your select statement to actually leverage it in your having. Why is it on?
Space.
Space?
Yeah, 2 dashes.
Gotcha. So here's an example where we're not showing that column, but we're leveraging it in a having clause.
Can you still add a where function here? Like select blah from blah where,
Mm-hmm.
and then a group by?
You can also, you don't have to have any aggregate function at all. I'm just going to turn this off just to show you.
New Jersey.
New Jersey's a better one? Something's wrong. I shouldn't get too fancy with my SQL because I really. Anybody see what I did wrong here?
You are required actually to for group by.
It's ordered
You
by
need
tree.
group by to have having. You need group by.
It's because
But you don't have to have you don't have to have an aggregate
Yes.
function in the select statement.
Yes, but you need to, if you have actual fields in your select statements, and you using having, you need to have group by these fields. And so it's
I think it should work
catch-22.
now.
I think group by requires aggregate functions.
Yes, it's catch-22. So basically.
It should work now. What happened was you're ordering by column 3, but you had commented out something.
Oh, that was why it didn't work. See? Okay. I'm going to do it again.
Maura also said that.
There we go. See? You don't have to have one. You don't have to have an aggregate function in the select statement.
But you need to have group by.
Absolutely.
Yes.
Yes. Absolutely. You cannot use having without grouping. The whole point of having something is because you grouped it.
And very important thing is that when you have having, let's say you have select average and you have having count star, it's all applied to the same group by. So this count also is applied to the same group by. You understand what I mean?
All right. That's having. Data modeling. So, what is a data model? Haberman, guys. He's my database idol. I love this guy.
You sure it's not Hoberman?
Hoberman. Whatever. I still love him. He might not love me because I just pronounced his name wrong. But I like what he says here about data models because I think they're so often ignored. And I personally wouldn't want to start trying to understand a new system without a data model. And we just published a couple for CB, and I know that Payomatic has a data model, and Lead Router may, or it may be an old one. But I like what he says here, which is that a data model is a wayfinding tool. Wayfinding. It's like an old traveler term, but it basically is, it helps show you the way through the data. So you need to learn what the symbols mean, or at least have some sort of cheat sheet nearby, and to understand how this works. But if you are exploring the data, a data model is so helpful because it gives you a set of symbols to explain how that data is related, and also shows you where you can have nulls. Data models are helpful for understanding what data is available, but also for how to formulate your joins and how to be wary of nulls. My preference for data modeling is the what's commonly referred to as crow's feet. I wanted to pull up this guide. What's going on?
Chris is clicking on that too. Also, the data model, like a lot of times, like non-programmers or the business side, and Vogel-An actually said it, like it's really important to be able to understand what's in the data model. I mean, you don't have to go in and look at the database, but when you're architecting a site and you're doing business requirements and you're saying there's going to be 10 data points, right, for some form that's being filled out, and you look at the data model and there's only 8 of those data points, like it's really easy to catch that when you're looking at paper before you've gone in and you're trying to get into testing, like why are we not recording this data? It's like because there's no field for it to go into or there's some error. But conceptually, it's really easy once Kristina goes through and sort of shows you what this is. It looks much scarier than it is, but it actually is very, everything there is explaining something to you in a very easy and readable way.
So, there are a couple of different kinds of notation. What I've noticed is that most data modeling tools default to the IDEF method, which I don't like. I don't think it communicates enough information. I don't like it. I don't think anybody should be using it with people on their team because it's just too ambiguous in my view. I don't think it communicates enough. In the example that I gave you is the information engineering example, and this is also commonly referred to as crow's feet, and this is why, right? So what we have here is a situation where you can have where the relationship of the foreign key to the primary key, that relationship can be 0 or 1. There can only be a 1-to-1. This is a 0 or more, or a 1 or more. And why does that matter, right? Well, I could have nulls here. I could have nulls here. This is, there should never, never be nulls. Never be nulls. 1 or more. I need to think about that when I'm trying to do a join, because I'm going to join a table with 1 to many values, and I'm joining to many values. So that means that it's going to increase my target table has 1 value, and the table I'm joining to has 3 values for every 1. Then these items on the other side are going to double or triplicate. So that's why we use data models that have already been produced to try to understand the data that we're dealing with. So let's walk through this. A city will have 1 or more addresses. Makes sense, right?
But maybe we should take a step back for people who've never looked at this word to sort of go through which line means what, like the table name versus roads versus other stuff.
Okay. These are tables. The city table, address, country, customer table. Everywhere that you see a little key, that means that this is your primary key. So just because we have a line here, that doesn't mean that's actually, that the column that it's touching, that doesn't mean that that's the column that it's actually joining to. In this case, right, it's city to city. You see that? And here it's country to country. These won't always line up, they can move anywhere. Sometimes there are indexes displayed, sometimes not, it's collapsed. These are what they're trying to show you here with this item as being empty, which means that it's null. It's possible that this could be a null value. But here what we're saying is that this is 1 or more, and the foreign key is city. The value is red, which is saying that it's a foreign key in this table. Just as country is red, it's a foreign key in this column. City is native to this table. It's not shaded out, therefore it can never be null. And city can never be null on the address column. We're saying that every address must have a city, and therefore this is a one and only one too many addresses, and it can never be null. And the same is true here. We have one country in this table. It can never be null. And only one. We can't have the same country repeated more than one time. And furthermore, well, obviously, you know, a country is made up of many cities. So the more that you start to do this, the more it makes sense to read it out loud, you know, or to read it in your mind. Of course, a country can have many cities. A city can have many addresses, and at one particular address, I can have more than one customer. So, again, guys, if you have a data model available on your team, get the model right viewer, pull that thing up, you know, stop using the queries that people are just handing over the fence to you, and start trying to build your own queries by using a data model, thinking about how those relationships should be formulated, and pull them together. But these links are here, and if your team is using these other models, you know, this is a nice cheat sheet. It's kind of worth just having this, and there's also some labels about how to talk about this stuff. Next. One to many. Many to many, one to one subqueries. One to many. I think we're running out of time. Do you want to barrel through the rest of this, or would you like me to shorten any of it? What would you like to do? Because we're running out of time.
What else is below slide 24?
We have these relationships, which we kind of just discussed. We have some subqueries here, and then inserts, updates, and deletes.
I think maybe we should skip to insert, update, and delete.
Okay.
What do other people say?
Go for help for subqueries, guys.
Subqueries is very useful.
Right, but it's also very, but deeper.
It's important but very complicated. You have to really feel stuff to start to do something.
Let's quickly do some queries.
I will show you an example. What's important to know about subqueries, guys, is just to think about math, think about order of operations, and so what we're saying here is this query will be to return a result, and so this value now is not static, and we only now want to return or count how many users have a rating equal to 93, and there happen to be 2. So these can get pretty complex. There's also the where exists model and different ways of doing subqueries. This is just one of them.
So this is returning a result that from a curated list, like you're pre-curating a list, and then you're returning a result from that.
Yeah.
Okay.
Actually, very often subqueries could be migrated to just simple joins. You just have to, again, to see, as Kristina says, to see and fill your data, because subqueries, sometimes optimizer does convert them to joins. Sometimes it does not, depending on how much rows are selected in the subquery. Sometimes it's nested loops, so you go through, and sometimes it just clap everything in one big join.
Yeah, you'd be shocked how some of these get evaluated. They get really complicated, but you know, that's where the fun is.
But
So-
also, I mean, you can also think, you could do that same query and say, give me everything
Mhm.
for these, and then you could say, now I wanna do the count
Yeah.
where it's just, just doing it. This is sort of this is giving you a much cleaner results, because you know exactly what you're looking for.
Right.
The other, when we're looking at the other thing, is you're getting the data back and sort of having to figure out what kind of question you're asking.
I want to add something. Very often, maybe in most cases, you want to use subqueries the same way as you use query from the table. So instead of querying the table, you using subquery and you alias in subquery, and you referring to the subquery by alias, same way as you referring to the table. That's very useful technique, actually. Kind of tricky technique, so but very powerful.
I like, I don't do this so much as I like to say, where there's also this other, like, from rating. Hold on. What is in this table? User? Let's just say. I don't think that's gonna, oh, we have to do join, so it's definitely, well, anyway, there are lots of different ways to do it. I wanna go over the insert updates and deletes, because I think that folks are gonna use this a lot less often than they may need to actually create create the data, and then we can come back to this one.
You really have to think in sets to be able to use it.
Yeah, yeah.
If you're able to think in sets, it's pretty easy to comprehend, but it requires some like learning code.
Right, pattern and pattern analysis. Updates. When we say we're going to update something, we tell it what table we want to change, we tell it what we're going to set, and where, under what conditions are we actually going to update something. Some important things to know is that if you need to set something to null, this is the one place where you set it equal to null. So, contrary to everything else we've set up to this point, if you need to update a column to null, this is the time when you say equals.
But Kristina's note here, do not set it equal to null the string, because that will ruin your data forever.
Because that's not really null, that's really something.
Wait, can you?
So if you, in this thing where you say set
I'll
it
show
to null,
you.
it's saying let's wipe out the data that's in that field.
Right.
We're setting it to nothing.
Right.
As opposed to setting it to quote null, that's saying set it to the character string that equals null. So if you were to run a query against that and say where is not null, that would show up as a value. It's actually just a string value. Or is null and you start missing it. But it looks like if you look at it in the viewer, it starts to get very confusing because you see numbers and it says null and you think that it's really nothing.
Let's take a look at the user table where the first name is for row number 2. William Clinton lives on Economy Street. Apparently that is real. That's where he really lived. If you could believe Bill Clinton lived on Economy Street. Think that's real? Anyway, select star from user. So what we're going to do is we're going to say, you know what? Who calls him William? Not me. He's Bill. That's Bill. Did it not do it? I complained so bitterly about this. Bet you somebody turned off the explicit commit. Something's not working.
Maybe the quotes of Bill. No. Bill.
The
Maybe.
single quote is
Yeah,
not
the single quote is stranger character. Maybe.
It's not that single quote, it's something.
Yeah, it's like an accent or something.
Yeah.
It's UTF.
Same for the.
It's the wrong thing,
You
it's
see
not
the
a
error.
tick.
If you click on the icon on the right side,
Yeah.
you can see
Yes.
the error.
Here?
Yeah, the middle. No, next to yeah.
Yes, it's the quotes.
You think you're saying it has to be like that?
No,
No,
it's
it has
single
single
quote.
quotes, but the other one wasn't single quotes, it was like an accent.
Oh.
So it's
Ah,
You
okay.
can tell because it didn't make it a nice color.
Thanks. Okay, so now I'm pretty sure.
No, didn't work.
And D equals 2. Yeah, and it's still not updated.
Safe update mode, and you try to update the table without using this mouse over.
You found that? Oh.
I think it's a character.
Oh yeah, because it's
So that's interesting. It'll allow it in the select, but not in the update.
No,
What
this
the hell?
application works in safe mode. We need to disable safe mode. That's what
You
it
just
is.
put your mouse over it, forget the whole message.
Oh, the ID. It's not ID. It's
Then using the key column, disable safe mode, toggle the alternate preferences, equals to generated and recommend.
Disable safe mode. That's it.
Preferences. I don't know where that is.
It is.
It's view.
Out of the bottom.
It's hard for me to read at this distance. I just can't. Anybody see
Or
it?
tab.
SQL.
Thanks.
So you have to reconnect.
And then reconnect. Oh, for God's sakes.
Yeah, one change.
Phew!
So could you have done the same thing
Oh.
where first name equals William?
Even though it already was William?
Well, you're changing it first, you're saying set first name to Bill, where first name equals William. Can you?
Oh,
Yeah, you can do that.
but then yes.
But you run the risk of updating all Williams.
All-
to
Williams.
Right,
Williams.
exactly. In this case, there's only one. Okay.
No, you still go row by row. How it works internally, you select all records for date by condition where you put where, and then you change it.
Well, you can do it with there's two Clintons, so you could do it on the last one.
Okay, I want to show you the null situation. So now we could say where now despite everything that we said before, this is a situation where you do say that it's equal to null, right? And so now instead of being William or Bill, he is null, okay? But if you had done this, you put some ticks in, now it really is null, right? I just want to point out, guys, that this database has commit on by default. It's like part of MySQL's default installation. And so anytime that you're running any updates, inserts, or deletes, you need to explicitly commit something. And if you don't like what you did, then you can say rollback. Inserting. there are two ways to insert. You can specify the values in the column or not. In this first example, we're saying insert into user, where the values are blah, 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 blah. The only thing that you need to know here is, this is kind of a shortcut in a sense, but as long as you have a value for every single column in this table, this works.
You can actually put null instead.
What was that?
You can actually put null.
Move?
Nulls, separate
Oh, right,
by
right.
columns.
Right.
But only for the fields that allow nulls.
Right. So Elvis Presley is on Hound Street, Hound Avenue, guys. But here, you know, again, this is sort of like the order by with column 1 and 2. I've had at least a couple of mantises here where inserts didn't specify the column values, and then there were columns added, and then they fail. So if ever you're putting an insert into your code, you really have got to specify the column names, because the columns can change. You can add more columns, and then this would stop working. Okay? All right. So Elvis is dead. We're going to delete the record that we just inserted. And I think this is, being able to do this is pretty key for, at least for testing purposes, testing the work that you do. Or testing the work that others do.
And also, you know, what Kristina was saying before is like, know like your target numbers. Like, this is also really important, looking at the actions. Like, if you put something in and you're trying to delete one record and you look and it says rows affected 9, well, you did something bad. You know, like if you delete it, whatever you're trying to do, you may just want to rethink what you just did.
Roll back. That's why it's really not great to have a commit on, for things to commit automatically. So
Just don't make mistakes.
Especially if you're dealing with a MySQL database, you should ask if it's auto-committing, because then there's no way to get out of trouble. And you know, you should be able to make mistakes and roll back. What's up? Any other questions?
Actually, could you go back to the data model? I just wanted to. Yeah. So in this picture, so one of the other things too that Chris didn't point out is in here where it says small int or varchar, those are field types. Varchar means it can be a number or a letter. Small int means it goes up to, I forget, 256. 56. And you can also have a tiny int, which goes up to 64, I think.
Maybe so. Tiny ints are 256.
Anyway,
I don't know.
The difference for this, and where this comes in, you know, why it's good to know this is because it allows, it's telling you what are valid inputs that can go into that field. So a lot of times by default, and this is no hit on any developers in the room, developers like varchar because they're really safe, right? They can put a number in, they can put a letter in, there's really no limitation on it, and except when it says varchar 50, that's like you have 50 characters, right? It's a pretty thing. Now the downside of that at the database level, it's very heavy. To store the number of bytes in that field, a varchar field is very big, so which is why there's integers, there's small integers, there's tiny integers. So when you start getting into a more mature system, and you'll see if we say let's start optimizing, you can, if you have 1 million records and you're storing an extra, you know, 1,000 bytes per row, and you start shrinking these down, you can actually really optimize the size of your database and sort of start leveraging your hardware. So it's good to know what these things are when you're looking at it.
So what is it for text?
Car. If it's just string,
Yeah.
yes, get characters. And each one, you can actually look it up. There's great things online for like MySQL. You can see the number of bytes it takes to store them. So you want to be really smart in trying to pick the thing like as small as you can fit into without hamstringing yourself. Like if you're going to have a value that's 0 or 1, right? It's a Boolean value. Like it's either going to be a yes or a no. You want to make sure that something like that is tiny int. And this is somewhere where like non-developers, like a lot of times when you're setting up these data models just by mistake, it's just missed. But you can get a lot of bang for your buck just really easily reviewing the data model and seeing something like that, or just to help understand what it is. A lot of times people are like, well, the data model is just for the DBAs and the developers. Like that's not really true. You can provide a lot of value with very easy changes up front.
Also, it helps you to envision which questions you actually can ask database.
Right.
Like if you have a time,
semantic meaning of the stuff.
That's it.